Welcome to our lesson on surface area. It shouldn't be much of a shock or a surprise to see that our goal here, our objective, is to find the two kinds of surface area that's associated with these type of shapes. We've got lateral surface area and total surface area of three-dimensional figures. But before we begin that process, let's familiarize ourselves with some vocabulary that's associated with these type of shapes. When we looked at the warm-up activity and dividing our three-dimensional figures into different categories, one of those categories was solids of revolution. Like this cylinder, this cone, hemisphere, and sphere, all of these things had curved surfaces. All of the other ones, on the other hand, had flat surfaces, and each one of those surfaces was a polygon, which gives rise to this word called a polyhedron. It takes its name, of course, from a polygon because it's a solid that's formed by polygons that enclose a single region of space. So you can see here we've got ourselves a cone, some sort of pyramid. This one's, what the heck is this one? It has two bases. It's not quite a prism like this one because this one has two parallel bases. This one that's on the top is at a slight angle. It's almost as if we had a pyramid, but somebody chopped it off, truncated it in some kind of way. So a single one is called a polyhedron, and more than one, plural, is polyhedra. And we do have different parts that we associate with a polyhedron. So first of all of the two-dimensional surfaces are called faces, and each one of those faces is a polygon, of course. The intersection of any two of those faces forms an edge, and that edge, geometric shape there, is just a line segment. And the intersection of three or more of those edges makes a vertex, and a vertex is just a point. All right, let's come over here, and maybe I'm going to highlight a little bit of this. So faces, again, they're the two-dimensional surfaces that make up your three-dimensional figure, and each one of these for a polyhedron should be a polygon, like that square has a whole bunch of just squares. Okay, now whenever I have the intersection of any two of those faces, it makes an edge, which is just a line segment there, right? And then finally, the intersection of any three of these edges, like 1, 2, 3, it makes a single point. Each one is called a vertex. More than one, they're called vertices. So there was this guy way back when, a mathematician, his name was Euler. He came up with lots and lots of math. He's got contributions to nearly every single branch of mathematics, very significant contributions, and one of them in geometry is Euler's formula, which relates these three things together. And it goes like this. You take the number of faces plus the number of vertices, and that should be equal to the number of edges plus 2. For every single polyhedron. So he was able to prove that that was true for every single polyhedron you can possibly imagine. So for example, let's just take like that cone? No, how about a cube? I want to take that cube here. So to draw a cube, you draw a square, and then you draw a square that's kind of offset from that, but I'm going to dash parts of it that are going to be hidden there. So I dash this here, connect these vertices. Look at this. It looks absolutely glorious. Or maybe I even shade in a part of this. Okay, sort of like that. Okay, that looks fantastic. So how many faces does this thing have? If I count up the faces, we'll think of a die. A die has 6 sides is what we call it, but in terms of geometry, it has 6 faces. All of them are squares. Okay, how many vertices does it have? Well, we've got 4 corners there on the top square, and then you have 4 more down there on the bottom square. So 4 and 4, we have 8. So that's a total of 14. 14 should be equal to the number of edges plus 2 more. Well, let's subtract that 2 from both sides. We'd have 12 edges. That's what we should have. Do we have 12 edges? Well, the top square has 4 of them, of course, but so does the bottom square. It has 4 of them. So that's 8 so far. And then all of these things that are called lateral edges, we have 4 more of those for a total of 12. What a smart guy that guy was. All right, so when we come back, we're going to take a look at some different kinds of categories of polyhedrons. We usually divide them into prisms and pyramids. What distinguishes those two? That's what we're going to examine in the next couple of videos.